Since the dawn of humanity, we have asked the question, how did our wondrous home come to be? Today, space technology casts light on this mystery. Thanks to intrepid astronauts and data beamed from hundreds of satellites, we are gaining new insight into Earth's epic history.
Going to space, we have a different lens to look at the whole planet.
We're finding fresh evidence to answer age-old questions about the formation of our solar system.
We can only understand the big picture when we study all these bodies and learn everything they have to tell us.
We're asking how life begins and how it evolves through times of peril.
All of these stories are intensely interesting murder mysteries in our planet's past.
We're going on a 4.5 billion year journey through eons of fire and meteor storms. From the arrival of oceans and freezing global ice sheets, through epic eruptions and mass extinctions, to where, against all odds, life finds a way. This is the story of the life of Earth from space. – 250 miles over our heads orbits the International Space Station. The astronauts who live here constantly monitor the world below.
Our vantage point from space gives us a view of the planet that is about collecting information that can't be collected any other way.
But they can also observe phenomena that provide clues to Earth's distant origins. The countless tiny meteors bombarding our atmosphere.
Every single day, there are thousands and thousands of pounds of space rocks pummeling the Earth. And it becomes very clear that we live in a neighborhood. It's made up of pieces of the universe, some of which come crashing down onto our Earth.
As they enter the atmosphere, most of these space rocks burn up, but those that don't can help us understand where our planet came from. 50,000 years ago, a large meteor punches through the atmosphere. The impact site is today visible from space. Arizona's Barringer Crater. When the 30-ton meteorite hit, it exploded into thousands of pieces. At the National Museum of Natural History, a major fragment is on display. The Canyon Diablo, one of the oldest objects you'll ever see. Radiometric dating reveals its oldest parts formed almost 4.5 billion years ago.
These meteorites hold in them a history of our solar system. They're sort of like fossil relics that have a story to tell about the birth of Earth.
It's a story that starts with the building blocks of everything on Earth. Elements that are forged in the hearts of long-dead stars. under its own gravity, an enormous star collapses. The explosion creates elements like iron, oxygen, and carbon.
The materials that we're made of, the materials that everything around us is made of, that Earth is made of, these materials, these elements are created in the centers of stars. And so we are made up of the ashes of exploding stars.
As gravity pulls on the stardust, it forms a hot spinning disk. A new star grows in its center, our sun. Around it, hot, dusty materials clump together. These small masses will become comets, asteroids, or meteors, like the Canyon Diablo. The largest of them become planets, like our own. The infant Earth is born. Its surface is a hellish ocean of molten rock, and it's missing a crucial companion. For humanity, the moon has always been a source of wonder. A timepiece to chart the months and seasons. Modern scientists are also captivated by our closest celestial neighbor. For them, it is the moon's origins that remain the greatest mystery. Is it a smaller body formed in parallel with the Earth, or a passing planet captured by Earth's gravity? NASA's Apollo missions provided a unique opportunity to find the answer. December 1972, the launch of Apollo 17. On board is Dr. Harrison Schmitt. On this last mission to the moon, NASA sends their first geologist. Scientists believe the secret to the moon's origins may be hiding in its rocks, if they can identify the right ones.
My mission was a little bit different because we built in some time for me as a geologist to look around and try to understand and more than a pilot astronaut, is however well trained they might be. They didn't have the experience that I did.
Let's see if I can't crack the corner and get that contact.
We actually collected more than any other mission, about 240 pounds of rocks.
With his carefully selected specimens, Schmitt hits pay dirt. These rocks prove that the Earth and Moon are more than just neighbors.
What those rocks showed is that the moon was made up of pretty much the same stuff as the Earth. And so that gave us the big clue that we needed to understand how the moon formed, but also understand the early history of Earth.
It's now widely believed that the moon is the remnant of a catastrophic collision. A newly formed planet, the size of Mars, heads straight towards the infant Earth. From the molten debris, our moon takes form. The same size as it is today, but 17 times closer.
It took a lot less time to orbit the Earth, and it took a lot less time for the Earth to spin once on the spin axis. So the day was shorter, the month was shorter, the week was shorter.
The proximity of this large circling object distorts the Earth, causing a tidal effect in the rock.
There was a gravitational interaction between the Earth and the Moon that we call the tidal force. And that has the effect of throwing the Moon away from Earth. So every day, the Moon moves a little bit farther away from the Earth than it was the day before.
Now, as the Moon rises for the first time, our planet begins to cool, and a crust begins to form. But before Earth can truly come to life, it must survive another harrowing challenge from space. The Moon's barren surface bears the scars of the distant past. In 1972, in the rocks around their spacecraft, Harrison Schmitt and the crew of Apollo 17 see signs of an impact so intense it melted the Moon's crust. They landed inside an enormous crater, 400 miles wide.
We were in a valley deeper than the Grand Canyon of the United States, so it was really a remarkable place to be.
The crater is one of many thousands that dot the Moon's surface. And analysis of Apollo rocks reveal many of these epic craters are truly ancient. Evidence that beginning some 4 billion years ago, the inner solar system suffers an intense bombardment.
The major thing that we have learned is that the first billion years of Earth history was extraordinarily violent.
Across hundreds of millions of years, the Earth is hit by over 22,000 asteroids and comets from the outer solar system. Some are over 25 miles across. Each one inflicts cataclysmic destruction.
What would that feel like? Constant earthquakes? Objects are streaking through the sky, falling to Earth. You feel the ground shaking, giant plumes of material being thrown up. That would have been amazing. There is lightning that's created in a plume of dust. There are rocks that are falling and look like they're on fire. There's going to be a lot of molten rock on Earth's surface as well. So you think of darkness, you think of lava, you think of the smell of sulfur.
As this assault continues, the Earth's appearance changes. Water starts to pool on the Earth's surface. It's thought that the comets bombarding Earth are laden with ice. This combines with water leaching from the Earth's own cooling rocks. The first oceans are born. With water comes weather. "1,000-year relentless storms of unimaginable ferocity. Every tide like a mega tsunami.
The Moon was much closer to the Earth, and this means that the tides were much greater. So instead of measuring tides in feet, tides were measured in kilometers or miles.
4 billion years ago, 500 million years after the Earth was born. It has a moon, oceans, and weather. It is beginning to resemble the planet we know. For now it is barren, devoid of life. But things are about to change. 2013, Chelyabinsk, Russia. A traveler arrives from deep space. It is the largest meteorite impact in a century. The hunt is on to find its scattered remains. Scientists pull a huge fragment from a nearby lake. They cut it open and make a fabulous find. The space rock contains primitive organic materials. It's the latest evidence to support a growing idea that the same comets and meteors that carried water to Earth also brought with them the ingredients for life. "4 billion years ago, auroras illuminate the infant atmosphere, the visual manifestation of the Earth's magnetic field, produced by its molten core. It's a shield that now protects the surface from the ravages of space radiation. Beneath this shield, in shallow coastal seas churned by the tides of the moon, fueled by volcanic heat and seeded with organic molecules from space, comes the very first life on Earth. Just how it begins remains a mystery. But at some point in this distant time, chemistry becomes biology. For years, no one believed life could exist in toxic volcanic environments. But life is full of surprises. Today, our planet is much changed, but there remain some environments bearing similarities to early Earth. Iceland, one of the most volcanic regions of Earth. Just off its southern coast lies an isolated volcano named Surtsey. Surtsey is one of Earth's newest strips of land. In 1963, it exploded from the sea, erupting continuously for 4 years. It is now a World Heritage Site, off limits to all except a few research scientists. Surtsey's hot volcanic cracks and seams closely reproduce the environment of early Earth. The team drills cores of rock from hundreds of feet below. They search for the fingerprints of life, marks made in the rock by deep-dwelling microorganisms. Despite temperatures exceeding 250 degrees Fahrenheit, without oxygen and in acidic, salty water, the rocks are clearly scarred by single-celled organisms feeding off the rock. Scientists are now finding these extremophile cells in volcanic zones across the globe.
It's mind-blowing, to be honest, because the number of microbial cells found in this system outcompete the number of stars in the universe.
DNA indicates some underground microbes relate closely to cells that were ancestors of all life on the surface.
It dawned on me at that time just how important they are. These are the type of cells that evolved into a more complex cell structure, which eventually turned into you and I.
$3 billion years ago, simple, single-celled life forms are now colonizing the planet. The oceans swirl with blue-green cyanobacteria. These have now evolved to harness the energy of sunlight. Through photosynthesis, the process still used by modern plants. This revolution in energy supply has massive consequences. Because the byproduct is oxygen. Over the next billion years, cyanobacteria turn carbon dioxide into oxygen in such volumes that the entire ecosystem alters. The crust of the earth and the oceans are filled with iron. As oxygen leaches into the system, this iron is transformed.
There was lots of iron on the planet's surface, but it had never been oxidized before. So fundamentally, cyanobacteria created oxygen, which created rust, and the earth became red.
By 2 billion years ago, the countless tiny microbes that fill the Earth's oceans alter the chemistry of the planet. But as it slowly evolves, over the next billion years, life will face a new challenge to its existence, as changes in climate plunge the planet into deep freeze. 720 million years ago, Earth is set for an explosion of life. But for now, life remains primitive and rare, and some scientists believe they know why. Satellite and ground surveys across a 2,000-mile stretch of northern Canada capture evidence of an ancient, continent-sized volcanic field. This is the Franklin Large Igneous Province. Many scientists now believe it's the sign of a series of enormous volcanic eruptions that threatened life on Earth by blotting out the sun. 1991, the Philippines. Mount Pinatubo explodes. It's one of the biggest volcanic eruptions of the modern era. Pinatubo pumps over 10 million tons of sulfur into the skies. Satellites later record a change in reflectivity of the atmosphere. So much heat energy bounces back into space, the whole Earth cools by 1 degree Fahrenheit. Imagine the impact of multiple Pinatubo eruptions, all going off at once. Northern Canada. Across 2,000 miles, the Earth tears open. Billions of tons of sulfur and ash clog the air. The Earth plunges into darkness. The eruption continues for decades. Global temperatures plummet to minus 50 degrees Fahrenheit. One theory suggests the freeze is so intense, the planet is encased in ice. Snowball Earth. Entombing Earth's fragile microbes beneath miles of ice for 80 million years. But eventually, the ice thaws. Somehow, life on Earth survives. And now, it will thrive. Across the next 200 million years, new generations of bacterial blooms raise oxygen levels again, creating an atmosphere rich in oxygen.
Looking at the Earth, especially at sunrise or sunset, which for us happens 16 times a day, which is pretty wonderful, that's when you can really see that layer, that thin atmosphere. And it's like a little bubble that encloses everything you know and love.
600 million years ago, this oxygen-rich environment is the catalyst for an energy revolution. Some microbes now turn from solar power to oxygen power. This new energy source is behind their evolution into the first multicellular plants and animals. Today, off the coast of Australia, lies the Great Barrier Reef. An organic structure so big, it can be seen from space. Scientists believe ancient reefs were incubators for early life. They are among the most ecologically diverse places on our planet.
Reefs are like cities. I mean, cities, you start with a few little houses, then you get buildings and multi-story buildings. There's lots of diversity in a city. So in ancient reefs, there's just that same thing. It's the more kinds of places there were to live, the more diversity of life forms there were.
In southern Africa, scientists have recently discovered what they believe is one of the oldest reefs on the planet. It was formed in oxygen-rich seas 550 million years ago. Evidence suggests this is a time of rapid evolutionary change. This is when the blueprint of modern animals, of us, first emerges. The Cambrian explosion.
What we see are a bunch of new kinds of organisms. Now, these were marine animals, small animals that looked like crabs and shrimp and other kinds of shellfish. These organisms had features that are quite familiar to us. If you look at a little tiny crab, he's got two little eyes looking back at you. He's got limbs, and he crawls around, and he eats stuff through his mouth, and it goes into his stomach and goes out the back end as his waste. That sort of way of being an animal we see for the first time in the Cambrian explosion.
Over 4 billion years, the Earth evolves from a ball of fire to a ball of ice. And by 400 million years ago, to this, a blue-green planet with life spreading to the land.
Pretty soon after you have the first plants on Earth, you have the first trees on Earth. With trees come forests, and with forests come the same kind of diversity of habitat that we've seen underwater in the reef structures.
With plant life comes animal life. The first surface dwellers make their appearance. Life now has a foothold across land, sea, and the sky. But their new oasis is a time bomb just waiting to explode. Russia. These are the Siberian Traps. An ancient lava field spread over 2 million square miles. In 2011, scientists here made a crucial discovery, explaining one of the most infamous events in Earth history: the Great Dying. This spot is the scene of the most deadly volcanic eruption in history. This huge area becomes an ocean of fire. But the danger is not just the eruption. Scientists found the lava erupted through a thick layer of coal, generating a toxic cloud that acidifies the atmosphere, leading to about 1 million years of deadly acid rain.
This eruption happens almost precisely when we see a lot of things go extinct at the same time. The lava starts erupting, organisms start dying. We call it the Great Dying because by our best estimates, it's pretty close to snuffing out life on the planet.
But not all life dies out. And the gaps opened up by the extinction generate a monstrous surge in evolution. The age of the dinosaurs. Argentina, 2012. Paleontologist Dr. Diego Paul uncovers the remains of what's thought to be the biggest land animal that ever lived. So large, its thigh bone alone stood taller than a human. The 70-ton Titanosaur.
You know, imagine 10 African elephants put together. You know, this animal was as long as an airplane, you know, a Boeing 737.
But dinosaurs were not always so enormous.
230 million years ago, the first dinosaurs appeared on our planet, and they were tiny animals. They were probably weighing 10 kilograms. Now, 50 million years after that, they were the first giant dinosaurs. This is the time when Titanosaur appeared and when they achieved the maximum body size, when we started seeing these 70-ton animals roaming on our planet.
It's not yet clear what caused dinosaurs like Titanosaur to grow so large. But these enormous plant eaters now become an important part of the global ecosystem. They travel hundreds of miles. They spread seeds and trample vegetation, creating new opportunity for plant species to spread across the planet.
We know these giant dinosaurs migrated from Antarctica to Asia to North America, Africa. They were everywhere, roaming through the landscape, altering and modifying the different ecosystems all over the planet. It's really, really amazing.
For 180 million years, as the continents slowly shift beneath them, the giant dinosaurs dominate the planet. But around 65 million years ago, suddenly, they disappear, wiped out by a meteor strike. Scientists believe another event may have contributed to their downfall. In India today, there is a collection of ancient temples. These incredible structures were cut from the soft rock of the Deccan Traps, the remains of a massive lava eruption that spreads over 200,000 square miles of western India. This epic eruption begins to poison the dinosaurs' world. But the nail in their coffin is the sudden impact of an immense meteor.
Here you have a body of rock that's 6 miles in diameter. It's traveling at 20 times the speed of a rifle bullet. When it hits planet Earth, which is much, much, much larger, it's like driving a truck into a stone wall. And it punches a hole deep into the Earth. And then all that energy gets blown back out of that hole.
With the force of 1 billion atomic bombs, the explosion gouges a crater 115 miles wide and nearly 8 miles deep. But many now believe that the impact alone wasn't powerful enough to cause their global extinction. Satellites designed to search for oil have recently confirmed that the impact site is a part of the Earth's crust unusually rich in hydrocarbons and sulfur. When the meteor hits, the volatile compounds vaporize, creating a cocktail of climate-changing chemicals that mix with the countless tons of melted rock.
All that energy blows up and out. Some of it goes out of the Earth's atmosphere. Some of it blows sideways. Meanwhile, the Earth is turning. So you have hot stuff flying out of the sky on the other side of the planet. If you were anywhere near it, forget about it. But if you're on the other side of the planet, forget about it also.
Nearly half of global plant life dies. Half the life in the sea is snuffed out. 3/4 of all life on the planet is made extinct. The great dinosaurs' fate is sealed. Although they disappear from history, the catastrophe now creates opportunity for others to take their place. "65 million years ago, after the devastating meteor impact, over thousands of years, the world slowly recovers. The air clears, the fires cool, and new forests take root. The great dinosaurs are no more. But some life has survived.
The mass extinction that saw the demise of the dinosaurs was terrible for everything on the planet, quite frankly. Mammals squeaked through that extinction. They did not sail through it by any stretch of the imagination. It might be as few as 20 different kinds of mammals that made it through that extinction. But the death of the dinosaurs really opened up a huge amount of opportunity for mammals, and they took it. They took the opportunity and they went wild with it.
On the northern borders of India lie the Himalayas, the highest mountain range on Earth. Today, its peaks rise 5.5 miles above sea level. But by Earth standards, these mountains are young, less than 55 million years old. This epic range rose in parallel with the rise of the mammals. "55 million years ago, after eons of continental drift, India smashes into Eurasia. The Himalayas begin their ascent to the heavens. Recent fossil finds in India are adding to evidence collected worldwide that this is an evolutionary turning point. The precursors of many key mammalian species are starting to emerge and spread across the globe.
10 to 20 million years after the dinosaurs go extinct, mammals really explored the world and developed a huge range of shapes and ecologies that still define them today. You start to see the first real horses. You see whales moving into the ocean. You start to see early primates showing up. But it was certainly a pivotal moment in mammal history.
For the next 50 million years, as continents continue to shift into today's positions, and the Himalayas inch upwards, the mammals evolve. By 1 million years ago, they take over the globe. And in Africa, conditions are ripe for a new chapter in the history of our world. A new mammal will emerge. A new type of primate that walks tall, who in a flicker of geological time will become the dominant species on the planet. Next time, we'll explore the age of humans, using clues from space to provide new insights into why we evolved our unique human brain, how we tamed the planet's animals and plants to build great civilizations, and how we develop total command of the Earth's energy, giving us the power not only to shape our future, but also the fate of the planet we call home.